Let's take a moment here and look at the graph of this equation. Actually, we're going to pause and take a look at several graphs here, and we want to look at some of the features of the calculator as well. Notice that we are going to be using the TI-83 Plus graphing calculator to feature on this program. Sometimes we'll also be using the TI-83. Now, if you have a different calculator or a computer software program, feel free to use those. It turns out that all of these instruments have remarkably similar capabilities, and even if the button sequence on your calculator is a little different, if you just do a little pecking around, I'm sure you can find the sequence appropriate for your calculator. Well, we'll be using or looking at this particular shot many times on our program. This is the viewing window, and we'll be seeing it all of the time. We'll see the buttons below, so there'll be no confusion when I talk about pressing the window button and then entering a particular menu. However, the buttons below we haven't looked at, and if you're unfamiliar with the calculator, it might be important for us to just have a quick peek at those and survey them just a little bit as an introduction. I'm just going to slide the calculator up a little bit here so that we can see those buttons a little bit better. Now, the buttons that are in this region, these two rows along with these four buttons, are sometimes called editing features. The most important items are, first of all, these four buttons. When I say cursor up, down, left, or right, I'm talking about pressing these buttons. They just kind of move an icon around the screen. The next most important button probably is this one. This is the one that's pressed when we enter a variable into the calculator. It's marked X, T, theta, and N for various kinds of variables in different kinds of modes on the calculator. Now, these two buttons allow us to enter areas that are above and to the right or left of the buttons down here. If, for example, we want to press the square root button, well, the square root button isn't a main button on the calculator. It's called a second function. Now, notice it's color coordinated with the yellow up here. So these have a color coordination to them. If we wanted to find the square root of 20, for example, then we would want to access this button, and to do that it would be second and then press this button, and we are entering that item onto the calculator, and then we would enter 20 and then equals. But at any rate, so the second function will allow us to enter all of these items that are to the upper left of the buttons below. In a similar way, the alpha button allows us to enter the letters of the alphabet that appear above and to the right of various buttons down below. The D, for example, is the alpha key associated with this one. So when I say, if I would want us to enter D, I would say press alpha D, you see, and what I mean is press the alpha and the D associated with it below, like this. All right, now I mentioned that these are basically referred to as editing keys. A lot of times these are referred to as advanced function keys. Of course, the clear is not so much of an advanced function, but these certainly are, and we're going to learn about those and other aspects of the calculator on a need-to-know basis. Now, the buttons below this row are could be called just scientific keys, because they are the buttons that are remarkably similar to those that are found on a scientific calculator. Now, I'm just going to try to slide the calculator up a little bit here so that we can see many of these. All right, a number of things are kind of important to us here. First of all, notice that there are two things that look like minus signs here. Now, this is actually the subtraction symbol, and this is the negative of. And this button also corresponds to the sign change button on a scientific calculator. The enter button corresponds to the equal button on a scientific calculator. Now, all of the four functions, the four regular functions, are over here. Notice opening and closing parenthesis. We'll be using those from time to time, and a comma button here that's useful for certain purposes. Now, raising to exponents is accomplished in a couple of ways. If we're simply squaring, we can press this button. For example, 5 squared would be 5, and then press this button and then enter, and we would get 25 on display. Now, so this button will square anything that is on display. All right, now if you are raising to a higher power, you need to use this button. So when I say the exponent button, it is this one. You see, and sometimes this is called the hat key. But if we were squaring 5, it would be 5 and then press this button and then a 2, and then enter, and that's 5 squared. Now, it's especially useful if we're raising, as I say, to a higher power. 8 cubed, for example, 8 hat 3, enter, that's 8 cubed. Okay, so that's the idea for the buttons that lie down in this region. Let's see, are there any others? I think that's about all that are in this area that we really need to be aware of right at the moment. Let's slide back down and actually enter some kind of equation. Now, you know, I mean, if I'm covering all the bases here, I need to say this, that in order to enter an equation onto the calculator, we need to write it in a particular form. Now, I'm going to just turn the calculator on, and you'll see some items here that I've entered using the alpha buttons, and the spacing was accomplished by using a space button in the alpha menu, and that space button is the alpha key on 0 if you're interested. But at any rate, if we have an equation written like this, in order to enter that equation into the calculator, we have to solve it for y. That is, we have to isolate y on one side of the equation. So to do that, we would add 2x on both sides, and that would give us this equation, and now we can enter it onto the calculator. Let's go ahead and do that. The equations are entered by pressing the y equals button, and then we could enter the 2x, whoops, only 1, 2, and the x, that's the variable key, and then minus 3, and now we're ready to go graph. Now let's just survey some buttons up here. The window button allows us to see the units that are designated for our viewing window. X minimum, -10, X max 10. Same idea for the Y's. Now these are just horizontal distances, and these are vertical distances. The X scale I'll talk to you about in just a little bit. The zoom feature allows us to zoom in or out in various ways, and we'll also investigate these in just a little bit. But do notice that we can zoom in on a box that we create. We can zoom in at a point that we designate. We can zoom out from a point that we designate, and so on. The trace feature we'll look at in a little while. Here's the graph of the equation that we just entered. Now, let me show you the trace feature. If I press trace and press the left or right arrow button, then an icon will move along the graph. And the coordinates associated with that icon appear at the bottom of the screen. That's real nice, particularly if we're trying to find something like, oh, let's say the x-intercept. Well, let's see. Now, the x-intercept, you know, the place where the graph crosses the x-axis, has a y coordinate of 0. So we would be looking for a y of 0 as we cursor along. And gee, we can't land on a y of 0 here. And that's really because of the kind of setting that we're on right now. We just can't land on that point. But we can change settings and allow ourselves to land on that particular point. For this graph, it turns out that the value here is a friendly decimal. It's just a little short decimal number. And so we need to just change the one little feature on the calculator. I'll go to zoom, and I can do a couple of things. I can press either item 4 or item 5, I think, and accomplish this. But I'm sure I can accomplish it by pressing item 4. Item 4 is Z decimal. Now the graph comes up. I'm pressing trace, and I'll trace on over to that point. You see y is 0. And now I can read the x as the x-intercept. It is at 1.5. All right, just one of the little features about the calculator. We're going to have more to say about that z decimal item in just a little bit. All right, now notice that let me go back to the standard settings, the default settings. Now that's item number 6 here, and we can access that item either by cursoring to it and pressing enter, or by simply pressing number 6. So either way, we go back to our original feature. Now, notice that the tick marks here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left of the y-axis. And I have 10 to the right, and I have 10 above and 10 below. Well, that's because of the window settings that we have right here. So we can redesignate that if we want to. Now, let's have a look at the scale situation. Back to the graph. Now, notice that there are 10 tick marks in all directions. If I go back to Window and set an X scale of, let's say, 2, and go back to the graph, go back to the graph, then notice that I have a tick mark at every other X unit left and right. Now the X scale on the Y-axis is still at 1. So that's what the X scale is all about. We can change it according to some kind of need a little bit later. Let's enter another equation. Suppose I go back to the Y equals menu, and I'll enter the equation that we were just discussing on the board a few moments ago. It's I'm pressing second and then square root, and remember it was the square root of x plus 4. So I'll press variable key and then plus and then 4 and then close parenthesis. Whoops, missed the 4. 4, close parenthesis. There we go. Now notice that the expression that appears under the radical needs to occur within a parenthesis here. On the TI-83 Plus, the opening of parenthesis is an automatic situation. On other calculators it may not be. So make sure you have the item in parenthesis. Now I can press graph, and I have both graphs coming up on the screen at the same time. If I want to look at only one of them, I can go back to Y equals, and I can deselect one of these graphs by cursoring left, and while the cursor is blinking on top of the equal sign, press enter. Now notice that what it does is it causes the equal sign not to be selected here. So I'm deselecting that equation for graphing. I go back to the graph, and I have the graph of only the one that is selected. So I can select, deselect as I see fit. Now let's go back and take off these equations. I'm pressing clear, cursor down, press clear, and now I just want to enter Y equals X and look at its graph. Now we're on default settings, I think. Let me look at the window settings. Yeah, except for the scale. The scale is generally 1. But the graph, notice, is angled at a certain way through the coordinate plane. And this angle is a smaller one than that one. And if this is truly Y equals X, then the angle right here should be 45 degrees. And the reason that it's not, the reason that the graph seems to be squunched down a little bit, is that the default settings say for us to have the same distance left and right as we have up and down. You know, the X minimum and maximum are negative 10, 10. And for Y, negative 10, 10. So that means a total distance here of 20 and a total distance here of 20. But the window that we're looking at is rectangular. So something sort of has to give here. If we're defining the same distance up and down as left and right, then we can think of what's happening here is that the graph is being squunched down a little bit like this, or the graph is being stretched like this. Either way you look at it, it's not a true square perspective. Now there is a button on the calculator that will automatically give a square perspective, but it's important that we be able to make the calculation ourselves. Let me show you an example. Suppose I go to the window setting and I set the Y minimum at, let's say, negative 4 and the Y max at 4. Now that gives us graphically a total vertical distance here of 8. Because this distance is 4, that distance down here is also 4. So total distance of 8. Now clearly we don't have a square perspective. To create that square perspective, we take this distance and multiply it by 1.5. 1.5 times 8 is 12. So we want this total distance to be 12. Okay, let's set that up. Now if we'd like that distance to be 12 and we want half of the distance on this side of the y-axis and the other half over here, then we're going to set our x minimum at negative 6 and our x max at 6. Let's go to the window settings and do that. So negative 6 for the x minimum, 6 for the x max, and here's the graph. Oh, that's nice. There's a square perspective. There's just one other topic I want to return